In this video, we're going to look at examples of solving application systems of equations. So you might have been thinking, why do I need to know this stuff? And so we're going to look at some scenarios where you can see how this might apply, hopefully in business, but with lots more variables. So this is just an introduction to this idea of systems of equations. But in business, there will be so many variables, sometimes you need a spreadsheet to keep track of all of them. So this first example says the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people entered the fair and $5,050 is collected. How many children and how many adults attended? Well, we can set up a system of equations where we have a variable assigned for the children and for the adults. So I'm going to go ahead and assign C for children and A for adult. Predictable, but that's what I chose. So now we can say that the children plus the adults were a certain number of people. We know that on a certain day, 2,200 people attended. And we know they have to be children or adults. So those are our two options. If we add them together, we know that we would get 2,200 adults and children combined. Now we need to talk about how much money was made. We know that there were so many children and each one of them cost $1.50 to admit. So C times that amount would give us the amount of money made off of children admitted to the fair. Now we know that adults were $4. So we know that 4 times however many adults would give us the money made for each adult that entered the fair. So total, we would know how much money was collected, which they actually tell us was $5,050. We now have this system of equations that we can solve. I'm going to go ahead and rewrite this 1.50 as just 1.5, and I'm going to take the dollars off. But remember, they are there. We're just simplifying the notation a little bit so it's easier to follow. Now the next step would be to figure out what you want to multiply the first equation by so that it's the opposite sign, but one of the terms will drop out. I noticed that 4 is a nice integer value, 1.5 is not, so I'm going to opt for a number that is the opposite of 4. I'm going to go for -4. That's what I'm going to multiply both sides of my equation by. Here we have, over here, the new equation. -4c minus 4a equals -8,800. And now we're just going to bring that other equation over. 1.5c plus 4a equals 5,050. And here we have a system of equations where the a terms will drop out. They will add to 0. And so then we can combine -4c plus 1.5c is -2.5c. -4a plus 4a is 0. And -8,800 plus 5,050 is -3,750. And now we need to solve for c. So we just divide both sides by -2.5. And let's see what we get. Feel free to just put this in your calculator. 1,500. And now we can use that number to find a. If we know that a total of 2,200 people attended the fair and 1,500 of them were children, that means that 2,200 minus 1,500 will give you the remainder. So 700 were left. So 700 were adults and 1,500 were children. Let's take a look at the next example. Suppose Lindsay's mom invests $10,000, part at 3% and the rest at 2.5%. Basically what this means is this person had extra money and they wanted to not just have it sitting in the bank, they wanted to let other people use it, but for that ability to use it, those people have to pay Lindsay's mom 3% and in another instance 2.5%. That's what it means by an interest-bearing account. The people who are borrowing the money have to pay Lindsay's mom a certain amount at 3% and in the other investment 2.5%. So that's why it was nice to have a little extra money. Not everyone does. The total yearly investments income is $283. How much did Lindsay's mom invest at each rate? Can you tell what the two variables will represent in this example? Well, we have two interest rates. We'll call it A and B. The total yearly investments from those two accounts is $283. So we know that from account A plus account B, Lindsay's mother made $283. But that's when a percentage is provided. So we don't know how much of the 10,000 was put in each, but we'll say that we'll make a little money bag here. Some amount of money was put in A and some other amount of money was put in B, investment B, and together they add up to this $10,000. So we're not quite there yet. We have A, we have B, but we need to include the percentage. So the percentage times the amount will give us the $283. Now, the simple part is just A plus B, the amount of money that was invested in each. We know that the sum of both investments adds up to $10,000. And now we simply have to multiply straight across by a number that will allow us to drop out one of these terms, solve for the other, and move on. So here we go. I'm going to multiply the second equation by negative 0.03 on both sides. And this is where a calculator will come in handy. I'll have negative 0.03a minus 0.03b is equal to, and now we need to multiply this. Remember, your shifting of decimals can be helpful. But we have 10,000 times 0.03. And it is negative. Let's put a negative in front of it. There we go. So that is negative 300. That is what I get when I multiply through both sides of this second equation by negative 0.03. Now let's rewrite the original starting equation here. 0.03a plus 0.025b is equal to $283. And now let's add them together. Negative 0.03a plus 0.03a adds to 0. Negative 0.03b plus 0.025b would be negative 0.005b equals. Now negative 300 plus 283 would give us negative 17. And now we can take negative 17 and divide it by negative 0.005 on both sides. And that will give me b is equal to, and that'll be a positive number, which is what we want. Negative 17 divided by, and I'm just going to arrow up here and say enter, and then enter again. So the amount that was invested in the second account was $3,400. And since I know that a plus $3,400 equals 10,000 total dollars invested, I can just subtract that 3,400 from 10,000 minus the amount given here, and I get A is equal to $6,600. As a reference, these examples were taken from Purple Math at the link here, purplemath.com/modules/systems probability.htm. And also the second example was found at She Loves Math at the given link here, www.shelovesmath.com/algebra/intermediate algebra systems of linear equations. You're welcome to go to either one of those websites to see more examples or explanation.